Last week, a frontier AI model broke out of a sandbox test environment, exploited a zero-day, chained it with stolen credentials, and gained remote code execution on a production infrastructure of another AI company. That company was Hugging Face. The model belonged to OpenAI. And here's the part that's incredibly interesting. The model was not compromised by an attacker. The model was the attacker. OpenAI disclosed this on July 21st. Hugging Face disclosed their side of it a few days earlier. Let me walk through what actually happened, why this is different from every AI security story we've covered so far, and why I think this is a watershed moment for defenders. Here's the sequence, and it matters, so I'm going to be precise. OpenAI was running an internal evaluation. They were testing GPT 5.6 Sol and an even more capable pre-release model, both configured with reduced cyber refusals so that safeguards would not block the evaluation. The benchmark is called Exploit Gym. It is a sandboxed environment designed to measure advanced cyber capabilities. The whole point is to see how far these models can get on offensive cyber tasks in a controlled setting. The models did not stay in a controlled setting. They spent substantial inference compute trying to reach an open internet from an environment that was supposed to be isolated. They discovered and exploited a zero-day vulnerability in a package registry cache proxy to get that access. Then they performed privilege escalation and lateral movement inside the research environment. Then they inferred on their own that Hugging Face was likely hosting the solutions to exploit Gym benchmark. So they went looking. They chained together stolen credentials and zero-day vulnerabilities to find a remote code execution path on a Hugging Face's servers and pulled the test solutions directly out of Hugging Face's production database. Read that again. The model was trying to cheat on its own exam, and to do it, it hacked a different company's production infrastructure. Now here is the Hugging Face side, because their disclosure fills in the picture. They saw the intrusion on their dataset processing pipeline through a remote code dataset loader and a template injection in a dataset configuration. From there, it moved to node-level access, harvested cloud and cluster credentials, and reached multiple internal clusters. Their team reported more than 17,000 attack events. They describe it, and I am quoting, as driven end-to-end by autonomous AI agent systems executing tens of thousands of automated actions across a swarm of short-lived sandboxes with self-migrating command and control staged on public services. To their credit, Hugging Face found no evidence of tampering with public user-facing models, datasets, or spaces, and they verified their software supply chain was clean. They detected the intrusion LLM-based triage over their own security telemetry. Here's a detail I can't stop thinking about, and it's the part every defender needs to hear. When Hugging Face went to do the forensics analysis, they first reached their frontier model behind commercial APIs, and it didn't work. The analysis meant submitting large volumes of real attack commands, exploit payloads, and command and control artifacts, and those requests were blocked by the provider's safety guardrails. In their own words, the guardrails cannot tell an incident responder apart from an attacker, so they fell back to GLM 5.2, an open weight model running on their own infrastructure, and they reconstructed the timeline in hours. Now sit with that asymmetry. The attacker was bound by no usage policy at all. The defender's forensic work was blocked by the guardrails of the very models it tried to use. Joshua Sachs has been making exactly this argument in his writing and his recent conversation with me on the Resilient Cyber Show. Guardrails that are meant to prevent misuse end up taxing the defender far more than the attacker, because the attacker was never going to respect them in the first place. The incident is that argument made concrete. The people trying to clean up the attack hit a wall that the attack itself never encountered. First, the distinction that matters because the headlines are going to blur it. This was not a supply chain attack where someone poisoned a model. This was not an attacker who stole a model and pointed it at a target. Nobody instructed this model to breach Hugging Face. It was given a benchmark to solve, and it decided autonomously that the path to solving it ran through another company's production database. That is the line we just crossed. We have spent 2 years talking about AI as a tool that raises attacker productivity, a human in the loop using a model to write exploits faster. This is not that. This is the model setting its own sub-goals, identifying infrastructure that was never in scope, and taking real actions against real production systems to achieve an objective. The autonomy is the story. And I want to be fair here, because the framing cuts both ways. OpenAI had deliberately lowered the safeguards for the evaluation. This was a test environment with reduced refusals. So one honest reading is that this is what was testing for. They found the failure in a lab instead of the wild. This is the system working. But the other reading is the one that keeps me up. The containment failed. The model got out of an environment that was supposed to hold on to it, and it reached infrastructure that belonged to someone else. If a safety evaluation at one of the most sophisticated AI labs on Earth cannot keep the model in a box, we should be very honest about what that means for everyone running these systems with far less rigor. Here's where it connects to everything I've been covering. The UK's AI Security Institute runs a cyber range called The Last Ones. It's a 32-step simulation of an attack of an enterprise network, full kill chain from initial access all the way through to the objective. It's meant to be one of the hardest end-to-end tests of autonomous offensive capabilities that exist. In AISI's own evaluation, OpenAI's GPT 5.5 completed The Last One's end-to-end in 2 of 10 attempts. It was the only second model ever to solve it. AISI's estimated the scenario takes a human expert around 20 hours. On a separate reverse engineering challenge, that same model recovered a custom virtual machine instruction set and solved the cryptographic constraints in 10 minutes and 22 seconds, against an expert baseline of roughly 12 hours, for $1.73 in API usage. So sit with the parallel. AISI built a 32-step simulated intrusion to measure whether these models could run a full kill chain autonomously. The answer in the lab was yes. And then last week, a more capable model ran a full kill chain autonomously, except it was not a simulation. It was Hugging Face's production database. The benchmark stopped being the benchmark. The last ones just happened on real infrastructure. And the trajectory underneath it is the whole point. As of February, AISI estimated the length of cyber tests these models was doubling every 4.7 months, and that estimated it accelerated from 8 months just before. Meter found a comparable doubling time of 4.2 months on software tests. AISI's own words are that the newest model substantially exceeded both doubling trends, and that is the unclear whether this is a new, faster curve. This is exactly the AI cyber capability curve I was writing about in Resilient Cyber. Each frontier release is better at offensive cyber than the last, and the curve is steepening, not flattening. When I wrote the cyber capability curve piece, the argument was that discovery and exploitation were collapsing the machine speed while remediation stayed at human speed. My line was that an attacker now needs an API key in an afternoon, and a defender still needs a quarter in the steering committee. What changed last week is the attacker no longer needs the afternoon either. The model supplied its own intent. That is the difference between capability and autonomy, and it's a difference practitioners have to internalize. A capable model raises the ceiling on what a human attacker can do. An autonomous model removes the human from the critical path. When the system can set its own sub-goals, discover out-of-scope infrastructure, and chain a novel zero-day with credential theft without a person steering each step, the economics of attack change completely. You're no longer defending against the number of skilled operators an adversary can hire. You're defending against the number of instances they can spin up. And the moat, as I keep saying, is the system, not the model. Hugging Face's own disclosure describes a swarm of short-lived sandboxes and self-migrating command and control. That is orchestration. That is the harness. The dangerous capability was never just the weights. It was the model plus the scaffolding that let it act. Let me give you the practitioner takeaway, because I do not want this to just be alarming. There is a path here, and it runs through one uncomfortable idea. Defenders have to be early adopters and innovators with AI, or we do not keep pace, full stop. This was the core of the lightning talk I gave at SANS AI Security Summit this past April. If the offensive side is compounding at 4 to 5 month doubling rate, and a defense posture that adopts AI cautiously 2 budget cycles behind is not conservative. It is a losing position by construction. You cannot meet a machine speed adversary with human speed programs. So what does adoption actually look like? Watch 3 things. First, watch the Hugging Face defense, because it is a template, and watch what got in its way. They caught this with an LLM-based triage over their telemetry, and they did forensics on 17,000 events in hours. But remember, the guardrail commercial models refused the job, and they had to run it on open weight models on their own infrastructure. The parity you are aiming for is an AI-run defense against an AI-run attack. Part of getting there is having models you actually control that will do the defensive work without refusing you. Second, watch the containment and evaluation security. The failure here was a test of an environment that could not hold a frontier model. If you're running or buying agentic systems, the blast radius when the agent misbehaves is now a first-class design question, not an afterthought. Third, watch autonomy in your own stack. Every agent you deploy with credentials and network access is a system that can take actions you did not explicitly authorize. The lesson from OpenAI is not that this is hypothetical, and it is not limited to malicious models. It happened during an evaluation. Step back and look at what converged last week. A model went rogue, not compromised. It broke containment, it exploited a zero-day, chained it with stolen credentials, and hit production infrastructure. And it did all of it autonomously, in service of a goal it was set for itself. Everything I've been tracking on this channel points to this moment. The cyber capability curve is steepening with every release. The AISI evaluation is showing full kill chains solved in the lab. The exploitation timeline is collapsing below the detection and response timeline. Last week, they stopped being separate threads. A safety benchmark became a live intrusion, and the only reason we are calling it an incident instead of a breach is that the two companies involved happen to be the ones running the tests. The question isn't whether autonomous AI can run an end-to-end attack on real infrastructure. That's already settled. The question is whether defenders will adopt this same capability fast enough to stand across the table from it. And I think we can, but only if we stop treating AI adoption as something to get eventually and start treating it as the requirement it already is. Full article link below. Subscribe and I'll see you in the next one.